This is the part 2 of video, and in the first video we talk about biological consideration, well, like biologic principles, and now we'll talk about the mechanical principles of tooth preparation in FPD. So the mechanical principles, or we can say mechanical considerations, are retention form, resistance form, and deformation. So what is retention form? The retention form is, it is a feature of tooth preparation that resists dislodgement of a crown in a vertical direction or along the path of placement. Okay, and the resistance form, it is the feature of tooth preparation that enhance the stability of a restoration and resist dislodgement along an axis other than the path of placement. If you will differentiate retention form and resistance form, so there is a difference between them. Retention, it is resisting dislodgement in a vertical direction or along the path of placement, but in resistance, it is resisting dislodgement along an axis other than the path of placement, and also it is enhancing the stability of restoration. Okay, so these are the features we can gain retention and resistance form. Number 1 is magnitude of dislodging forces. Number 2 is geometry of tooth preparation. Number 3 is taper. Number 4 is freedom of displacement. Number 5 is surface area. Number 6 is stress concentration, and number 7 and number 8 are interrelated. So number 7 is film thickness of luting agent, and number 8 is type of luting agent. Number 9 is type of preparation, and number 10 is roughness of surface being cemented. So it is not ended here. Now we will talk about from 1 to 10 features to gain retention and resistance form in detail. So first of all, we'll talk about magnitude of dislodging forces. Depends on the stickiness of the food and the surface area and texture of the restoration being pulled. So it is a very important retention and resistance form. One, having a restoration is not allowed to eat sticky or chewy foods. Okay, because if they will eat these type of foods, it will eventually result in restoration being pulled. Okay, the second one is geometry of tooth preparation. Most fixed prostheses depend on geometric form of tooth preparation rather than on adhesion to retention, as most of the dental cements are non-adhesive and adhesive. So the geometry which is very good for tooth preparation is cylindrical preparation. So number 2 is taper. So what is taper? It is the convergence of two opposing external walls of the tooth preparation as viewed in a given plane. You can see, so the taper you can see the axial walls should converge occlusally. So what are the axial walls? The axial walls are the one dotted lines you can show, and there is 3 degrees showing. So these are the axial walls, and they should converge occlusally. So occlusal wall is the wall which is showing the arrow and there is written 6 degrees, so that is the occlusal wall. So you can see the walls are parallel to each other, so the walls should be parallel to each other and they should converge occlusally, so there will be eventually greater retention, and recommended convergence between the opposing walls is 6 degree. So the number 4 point is freedom of displacement. Retention is improved by limiting the number of paths of insertion. You can see only one path, there will be maximum retention. If there are multiple paths, then it will result in minimum retention. So how you will retain and how you will get retention? Of course, by providing grooves. I will give you example. You can see there are some toys that have holes, and you can open it and also close it. So there are some grooves in them, like circle ones, and the other part of the tooth can easily fit into the other part of the toy. Okay, so it may be a confusing. You can just see in the first picture, there is a gray there is some gray part that is showing the groove and the arrows going upward. So there is only one path of insertion, and there will be only one part of removal. Okay, but in the other picture you can see there are multiple paths, and it will eventually result in minimum retention. So by providing grooves we can enhance the retention. Okay, now the other one is surface area and length. So if there will be longer preparation, more surface area, there will be more retention. Okay, now surface area should be more and the length should also be longer. It will result in retention great enough to interfere with arc of casting pivoting about a point on margin opposite to side of preparation. So the length should interfere with the opposite side of the preparation with an arc of cast pivoting at a point. I want to add a picture of it because it is a little bit difficult to understand, but I just forget. Sorry, next time I will add it. So the other one is stress concentration, number 6 point. So retentive failures begin at junction of axial and occlusal surfaces where stress is concentrated. You can see the first tooth in which the cross arrow is showing. So there are the mainly that is the junction of axial and occlusal fall, and that is the area where stress is concentrated. So how you will remove, how we can solve this problem, like there should not be stress concentrated at this area. So this can be achieved by rounding the internal line of angles. You can see the arrows showing this of the second tooth. So these line angles are rounded line of angles, that is a junction between axial and occlusal wall. So it will reduce in stress concentration. And the type of preparation. So which type of preparation have more retention resistance? Complete crown are more retentive than the partial crown have less retention. So the roughness of the surface being cemented. Why it is important point for retention and resistance, and why it is needed? Why? So, surface roughness or roughness is defined as the irregularities which are inherent in the production process. Why it needed? Because it increases retention for a crown, so it is a good thing. But how we can? Why? So adhesion of dental cement depends on projections because of the projections of cement into microscopic irregularities. So if there be roughness in the surface of the tooth which is being prepared for restoration, there will be roughness, there will be irregularities, and there will be then projection of cement more easily, and it will result in retention resistance. So type of luting agent is also important. Why? Luting agent, it depends on the compressive strength and modulus of elasticity of luting agent. Following are the types which have good compressive strength. So there are luting agent that do not have compressive strength, or there may be difference in one have more strength than the other luting agent, the other one is more greater strength than the other. So that's why we have to look which type is good. So these are the following that have good, but they may be resin, glass ionomer, polycarboxylate, and zinc oxide eugenol. So what is the film thickness of luting agent we needed? 50 micron is more retentive, but up to 120 is acceptable. So deformation is the third point of the mechanical principle in tooth preparation, and we should prevent restoration deformation. So how we can prevent it? The restoration must have sufficient strength. So how to prevent it? The strength of the material is very important, and we already talked about alloy selection, nickel chromium are have more strength than the nickel chromium. So it is a more good material, and it will prevent deformation. You can see the crown, and there should be adequate tooth reduction, as we have already discovered about a point. The length, surface area in length, there should be greater. It will be longer length and more surface area, and the axial and occlusal reduction is less. Then it will result in more resistance and less deformation. Okay, and the fourth one is also explaining the same thing. There should not be over contouring and poor occlusion. In biological consideration, we have talked about what do you mean by poor occlusion? Grooves and edges are very important because if there will be no freedom of displacement, we talked about in that point, there should be grooves and edges, deformation, and it will prevent deformation. Okay, so the third principle of tooth preparation is aesthetic consideration. So patients prefer their dental restoration to look as natural as possible. Of course, all patients need their artificial teeth look as natural as the natural teeth, of course. So this can be achieved by minimum display of metal. There should be minimum display of metal while we are giving a crown. So the crown, we give a combination of crown means that the inside part of the crown is metal for better, because metal is very good. Anyways, it has many advantages and durability. Okay, so the other point is maximum thickness of porcelain material to enhance the shade of the color. So this means like I've already talked about there are different crowns. We'll talk about in some other video that different types of crown. So it is a crown like porcelain metal crown, we can say, or metal porcelain crown, MC crown. So in MC crown there is the metal inside and there's porcelain outside. So the thickness of the porcelain should be maximum. If the thickness is maximum, the shade of the metal will not enhance, okay, the restoration. And that's third point is also the same. We talked about the shade selection is also very important, like it should match the other teeth that is beside to the artificial teeth. And the number 4 point is porcelain occlusal surfaces. Aesthetically, no metal appearance is more preferable by the patient. Very important. As we have already talked about in biology consideration about the gingival margins, which one is better, if it's subgingival or supra or equigingival, they all have their advantages and disadvantages, okay. But subgingival margin is more aesthetic and it is more preferable, because subgingivally the there will be, if there's metal collar, there will be minimum display. That's why it is one of the advantage. And thank you for watching this video. If you like this video, please comment, share, and also subscribe. Don't forget to subscribe it and note it down. This is a detailed video.